So good morning, everybody. My name is Mike Terry, and congrats to everybody for making it to the end of the Capstone course here. This is my curriculum project, which is an energy and sustainability curriculum. First, we can talk about the literature review. So in my literature review, I came up with three, main themes here. The first one being traditional energy use, such as oil, coal, nuclear power generation, and natural gas. So throughout these, traditional forms of energy, we found and seen, a great technological, advances in the field. As well, there have been technological advances in the field of alternative energy use, such as solar and wind. Um, Additionally, we can talk about sustainability. So that's the third theme that I had here. It's really how one and two, the traditional alternative energy forms, are used in a sustainable manner, and caring for the earth, if you will, creating technology that ameliorates the impacts on the earth and all the living organisms on it. Um, right here, I want to bring this graph up. This graph right here shows the correlation between temperature and carbon dioxide for the last 400,000 years or so. And you can see the temperature being red and carbon dioxide being blue. You can see where levels are at in 2007 and continue to rise, without the temperature increase just yet. But there's clearly a need. We can say that in this field that the populace needs to be educated on, what sort of impacts humans are having on the earth. So how I developed this curriculum is, first of all, with incorporating physics. I'm a physics teacher by trade. I wanted to take the Common Core State Standards, which are college and career expectations, and sort of develop my curriculum with those in mind. So getting students ready for what lies ahead after secondary school. Additionally, the next generation science standards and how they relate to New York State's NYSSLS, so New York State Science Learning Standards, developing them together. So the next gen science standards have three main ideas, which are core ideas, cross-cutting concepts between different pieces of curriculum, and scientific practices. But one of the biggest pieces of the next gen science standards are actually, engineering design. So getting students, building things, as well as an inquiry. So students being given a problem and it's their task to make their own solution to the problem, without a cookie cutter recipe of how to do it. So really giving students some freedom and some control over their own learning is what the next gen really is going for. As for the curriculum, we have six main topics. We'll talk about briefly, each one briefly. The first one is Earth systems, climate change, and an introduction. So the picture you see in the background is just the carbon cycle, talking about how carbon is exchanged between the atmosphere and the oceans, and how humans are impacting it as well, as well as photosynthesis, which uses carbon and emits oxygen. So there's the carbon cycle on the Earth. We're talking about human contributions to carbon, having students complete a carbon calculator, so hopefully seeing their footprint at home and their own lifestyle, as well as getting some kids to do some internet research. So not formal research where we're sourcing and presenting much on it, but just sort of getting kids acclimated to using the internet for some research. Two is power generation, electrical circuits, and electrical storage, where we talk about how electricity is made and how it's stored. We talk about electrical circuits. Again, physics teacher by trade, so we're going to be incorporating these physics practices in that core curriculum throughout. A bulb brightness lab between series and parallel circuits, and we also get kids using multimeters here. So again, a college and career technical readiness skill. Numerous trades use multimeters, in the real world. Last but not least, we talk about batteries and the cost of electricity and saving on electricity. So analyzing electricity bills from home, looking at rooms and seeing how different bulbs, i.e. incandescent versus fluorescent, versus LED can be used, and how that initial investment, can pay off in the long run. Here's the percent of total U.S. energy consumption in 2016 for all of the major sources of energy. And this traditional unit, we're going to talk about oil extraction, unconventional oil and fracking, hydrofracking, if you will, nuclear power generation, coal power generation, and we're going to start getting kids using database research and sourcing. So starting with that internet research, moving into databases, articles, and actually starting sourcing them. Here's the percent of total U.S. energy by electricity generation. So what are we using to actually generate electricity? In this lab, we're going to be talking about solar power generation. We have a solar race car lab that we're doing. Geothermal heating. We're going to bring in a guest speaker. Again, that career component, exposing students to, something that they could get into as a career surrounding this field. Sustainable engineering. So talking about what college campuses, what other places are doing as far as infrastructure, sustainable transportation, different things like that we'll talk about. And planning inquiry investigations, which is the big one. So we're scaffolding students up to planning their own investigations by this one's cell phones. I'm just going to put some cell phones in front of the kid, give them some materials, and say, hey, figure out what makes a touch screen work. Is it not telling kids this necessarily, but is it temperature? Is it pressure? Is it texture? What is it that makes a touch screen work? Letting them plan their own investigation. 5 is going to be wind energy, resumes, and inquiry projects. So we talk about wind power generation. We take them on a field trip. Again, getting that college and career component, all while talking about the physics core curriculum and interweaving that next-gen science standards. We're doing an inquiry investigation. So this is scaffolding it up and sort of letting kids, fly on their own. They have their wings here, now fly. And when we say turbine specifications, we're saying, what number of blades, what size for the blades, wind speed, fan type, what is the best specifications for a turbine in the classroom. We're going to do some vernier data collection, which is a more sophisticated form of data collection, more similar to what experts in the field would be using, of course on a scaled down version, but again, next gen and Common Core all together. Making a resume and finding jobs are some big ones to go along with this as well. You'd be so surprised when, in a classroom, how many of you students have a resume? A couple hands pop up. How many of you don't know what a resume is? More than half of the hands generally pop up, at least in my school in 11th grade. So we're really getting some kids practice in making these, as well as using the internet to find jobs. That's a skill, that's a literacy that students need to be able to do when they graduate from secondary school. Last but not least, wrapping up the unit, we're going to be doing a service learning project. So students are going to incorporate everything that we've done throughout the unit, conducting the research, online, sourcing, everything, demonstrating knowledge of the content, which would be the next gen and the New York State Science Learning Standards, using technology. We're going to be making brochures to distribute, and this technology is something, as far as computers, making a product on the computer to be shared with community members, communicating scientific ideas, which is huge, huge, huge. Common Core. How can you communicate these ideas? As well as we're gonna, benefit the community hopefully with giving them some knowledge on some of the stuff that we've learned. And again, that's the wrap up for the whole project there. Sources, Capstone sources, and Capstone sources. All right, thank you everybody very much. Again, good luck with the rest of your semester, and take care now.